So there's nothing new per se that we're doing today. It's more about observations and problem solving. We're still just using this formula. And remember, the required input for this formula is always, you need a point on the line and the slope of the line. If you're given slope and a point, sometimes, like the learning goal we just took up, you're just given them directly. There's no work to do. But sometimes, as you're going to see in the first example, you're given them indirectly. So there's some work or an observation you need to make before you can do that. So you have to figure out what the slope is. You're given the slope, but you have to figure out what it is, state it. You might have to find the point, state it, and then use the equation. But you're always, always, always coming down to finding slope and a point in order to use this formula. If instead of giving slope and a point, you're given 2 points, again, you might have to go find those 2 points. And then there's an extra step where you have to use the slope formula to find the slope between those 2 points. So then you're using this formula first. Then you have slope and you pick whichever point you want and you go back and use point slope formula. And all of these questions, of course, there's going to be some overlap and they're going to be similar, but they're all a little bit different. They're all worded in a bit of a different way. So the problem solving aspect is you have to be able to read through the question and understand what it's giving you and how it's giving you the slope or how it's giving you the points and how you find them. And that's what today is about. Tomorrow we sort of take a break from equations of lines and we talk about something else. And then we use that something else to do more of this problem solving stuff. And this is what we're doing for the rest of the unit, basically, is this kind of problem solving. That make sense? Okay, so let's try the first one. Find the equation of each line and write it in standard form. A line that goes through this point and has the same slope as this line. This is a different line. We're not coming up with the equation of this line. This is a totally different line. Okay? But the line we're trying to find the equation of has the same slope as this line. Do you see how this works? So this is a question where we're given either slope and a point or 2 points. Which one is it? Slope and a point. And I'm actually going to write that down. You don't have to, but it's not a bad idea. It focuses your thinking. Remember what I've said this a few times. Problem solving is like you're given a question that has a whole bunch of parts, and that can be overwhelming. So one of the best things you can do is break it up into smaller parts. And the first part would be figure out, am I being told about slope and a point or 2 points? So this is slope and a point. And even if you don't write that down, you should be thinking it in your head. I'm being told something about slope and a point. Are you given the slope directly? You might say yes because it's pretty easy to find, but I would say no. You're not told the slope is -5. You're not told that. So that's not directly. So we have a little bit of work to find slope. And normally I wouldn't write all of this down. You would just kind of state the slope, but I'm going to write it down for our thinking today. So we are told same slope as this. So what do I do? I'm sure somebody in here knows what to do. Help me out here, folks. Hold on. Stop there. We're not told anything about the y-intercept. Oh, of this line, the y-intercept is -5, right? Does that have anything to do with the line we care about? It does not. So you're right. This is the y-intercept of this line, but we don't care about that. All we're told is the line we're looking for has the same slope as this line. And the slope of this line is -2. It's right there. Which means the slope of the line that we want is also -2 because it's the same. See how this works? Okay, what about a point? Are we given the point directly? Yes. We're just given the point through this point. So my point is this. Do I have the slope of the line that I'm looking for? Yes. Check. Do I have a point, any point on the line that I'm looking for? Yes. Check. I'm ready to use point slope formula. Y minus y1 equals m times x minus x1 at a slope of -2 through the point -2, 6. Hey, and we'll go through this quickly. You don't have to copy my steps. You can do this yourself for some extra practice, but I'll do this quickly. We've done this lots of times. Really, I mean, this is good practice, don't get me wrong. Every time you do this, you're going to get more practice doing this to make sure that you're doing it correctly. Every time you do one, check that you got the right answer in the answers that are provided. And if you're not getting the right answer, reflect on that. That's the whole point. Whenever you're doing homework yourself or practice yourself, you check your answer. Did you get it right or did you get it wrong? And reflect on why and try to look for your mistakes and improve constantly, right? But today is more about the setup, I think. So I move everything to the other side. 2x plus y minus 2 equals 0. Oops. Because I added 2x, and I added 2x, and I added 4, and I added 4. Okay, done. Problem solving is interesting because for some people it just comes naturally and to other people it doesn't, and they really struggle with it and find it hard, and they read a question like this and they just don't really know what it's asking. So again, you've got to start explicitly using strategies. What I mean by explicitly is think of the strategies and pick one and just do it. And don't think about the bigger problem, just think about that one part. So what did I say was the first thing that you should think of when starting these questions? Okay?
What is the equation or what's the sentence whatever giving you?
You're right. So it's either giving you slope and a point like the last example, or it's giving you 2 points, or it's talking about 2 points. And you can use those 2 points to find the slope. So which one is this? How would you know? Does anybody know?
You're given 2 points.
2 points. Did anybody else think that was the case? Some people unsure and not really. So how would you figure that out? Well, look, through 1, 1. So that's a point. Same y-intercept. Is that a slope? No. Y-intercept isn't a slope. It's not giving you a slope. It's talking about another point, a different point. So this one is definitely 2 points. So point 1 is easy because it's given, so it's 1, 1. What about point 2? Like, step at a time. You may not know what the y-intercept of that is. You don't have to yet. You just have to recognize that it's trying to give you a point. So we got that far. Now I switch modes and I say, and I forget about the whole question. I forget about the equation of the line. I forget about slope, all that stuff. And I just say, how do I find the y-intercept of this line? Anybody have an idea? Be careful. In standard form, you can't just pick it out of here. So if you're doing some work in your head, you might be able to figure it out, but we're not sure. Lily, you had your hand up? I think that's a great idea. In the form y equals mx plus b, the y-intercept is right there. So if I can rearrange this into y equals mx plus b, then I can just pick the y-intercept out of it. So let's try that. So for point number 2, I'm starting with this. I should have put it down further. And I'm going to rearrange. So I want to move the x and the constant to the other side. So I'm going to subtract 4x, subtract 4x. This is like the opposite of all of the putting it in standard form that we've been doing kind of thing, right? And I'm going to subtract 6 and subtract 6. So I end up with negative 2y. Don't forget the negative. Don't forget the 2. Equals negative 4x minus 6. What do I do next? Very nice. Divide by negative 2. What do I divide by negative 2? Everything. So this becomes y equals. Now I'm going to be in y equals mx plus b form because I've got just y. Negative 4 divided by negative 2 is 2. Negative 6 divided by negative 2 is positive 3. I don't care about the slope of this line. The question didn't say anything about slopes. I have no idea if the slope of this line is related in any way to the line we're looking for. All it said was the y-intercept is the same. So, what's the y-intercept of this line? 3. Therefore, what is the point? What are the coordinates of the point? 0, then 3. Make sure you get it in the right order. 0x, 3y. If you have to, off to the side, scrap paper in your mind, do a little sketch. Well, the y-intercept would be there. That's a y value of 3 and an x value of 0. Visualize these things, right? Okay, what do we do next? Find the slope. Very good. We want to use point slope formula. We need slope and a point. We've got 2 points, but we don't have slope. But we saw yesterday, and we've seen before, we can find the slope between 2 points, so we do that. So now we find slope. And now you can start to see why I organize my solution like this. It helps me focus my thinking. It helps me show what I'm doing for each part. Not just for like the person who's marking it, but it will help you stay organized as well and remember what you're doing. So these are the 2 points that I'm using, point 1 and point 2. So the y value of this point number 2 is 3 minus 1 over 0 minus 1, which is 2 over negative 1, which is negative 2. And then I do equation. And this is why it seemed redundant. It seemed like we were just writing the same thing over and over and over again. But this is why I always write what I'm using in the equation, is because now I got all kinds of different things scattered all over. And not tomorrow, but starting on Thursday, it gets even more complicated. You have more things written down. So just to clarify, not just for me, but for you, I always rewrite what I'm actually using. So I'm using this slope that I found. And which point should we use?
I did 1.
Yeah, point 1. I mean, 1 is an easy number to use. Some people might choose this because we said yesterday it's got a 0 in it. But, you know, like it's entirely up to you. Okay, so Caleb used 1-1. I'll use 1-1. If you want to try 0-3, you can. Again, hopefully we're getting proficient at this. As I said, reflect on if you're getting these right or getting them wrong, if you're making mistakes, and really reflect. And this can be hard, and this is why coming in for math help or asking questions or working with a friend or something like that can really help. Reflect on what the mistake you're making is. Did you get -1 minus 2 wrong? Like, did you just do the integer math wrong? Or did you do this part wrong? Did you sub in wrong? So was it a mistake in your mechanics and just your multiplying or adding or subtracting? Or was it a mistake in the process, the procedure of all of this? Or did you not know how to find the point? Or did you not know how to find the slope? Like, where's the part that you're having trouble? And often, I find students can narrow it down to it's the same kind of mistake that they're always running into. I think we know how to solve this one because this is the same kind as what we did yesterday. Some of them are going to be different. Some of them are going to be similar. So go ahead and try this one for extra practice. Or at least get it started. So I hope you notice that this is 2 points. In this case, you know, it's maybe not as necessary. But if we're going to follow that. And we already have both points. We're given everything, so we can just start by finding the slope. What happened? How many people already found the slope? Did you get the same thing as me? Very nice. What does this mean? What happened? Undefined. Very good. And I've noticed that people are getting a lot better at that. And they, like, you know, at first we were forgetting what it meant and we thought this was 0, but more and more people are getting this correct. So this is undefined. Now, because this was -3 minus -3, which you notice I wrote as -3 plus 3, which is 0. What does that mean? What does a line with a slope that's undefined look like? Okay, no, don't say it's on the y-axis. It looks like the y-axis. It is a vertical line. You're exactly right when you say that. It is a vertical line. This is a special case. Okay, and I'm gonna write that down. You don't have to always write that down, but we're doing it for our note. Special case. You could use the formula to do this. It's a little wonky. I'm going to say there's a better way. And again, I'm just going to write this off to the side. Special cases are horizontal and vertical. And a horizontal line looks like this. So if you look at that, this is what, again, you have to be able to visualize this, I think. And you look at this and you say, what's not changing? Y isn't changing. So Y is always something. So Y equals some value. So a horizontal line is always of the form Y equals something. A vertical line looks like this. What's not changing? X. X is always the same. So it's X equals something. So a vertical line always has the form X equals something. I would visualize this. If you have to draw it, draw it. Sketches like this are a big part of good mathematical thinking. Many, many people want to separate the algebra from the graphing and the visualization. They go hand in hand, they help each other. Okay, so this is a vertical line. It's x equals something, but I can even see that. What does x equal? -3. Like, look at it. The y's are changing and the x isn't. And for this one, I just go, therefore, the equation is x equals -3. I can visualize it. If you really wanted to, you could memorize this. Horizontal is y equals, vertical is x equals. Or you can look at the coordinates. The x isn't changing, so x equals -3. Like, you can do it that way too. There's so many different ways you can think about this. Be careful of the special cases. You can use point slope formula. For vertical line, it's tricky, it's weird. So if this isn't working for you and you can't do it, I'll show you that, but you're going to have to ask me about it. I'm not going to do it in front of everyone because I think it'll confuse things. I think the best thing is just good mathematical thinking, is recognizing this is a special case and handling it in a different way. Okay? Does that make sense? I think we probably have one more here. Oh, there you go. What about a vertical line through this point? So as a vertical line, we just did this x equals or y equals. We know that it's a special case. You have to figure out which one. Vertical line is telling me something about slope, right? It's telling me the slope is undefined. It's also giving me a point. So it's kind of giving me slope and a point, but really this is a special case. And again, I might do a little sketch. And what I'm going to do is I'm going to plot this point. So watch. -2, 4. I don't care about the scale. And I'm going to draw a vertical line through it. And this vertical line is going through the x-axis. So that tells me it's x equals, and it's going to be x equals that value. And you just write it like that. Does that make sense? And this is your warning. It is not obvious. People will get it wrong. Because this looks like the y-axis, they think that the equation should be y equals. But the y's are changing, so that doesn't work. It's x equals. Okay? So you could do it by just visualizing. You could kind of remember it, memorize it. You could remember that it's just opposite of what you might think. Or you could draw a line through it and see that it's crossing the x-axis. That means it's x equals. By the way, if you're supposed to put it in standard form, we would have to move that 2 over, wouldn't we? Okay? Any questions on that? Be mindful of the special case. I'm going to go back up and I'm going to revisit this one, and sort of, you could do this one the same way. So I've got -3, 5. And -3, 7. And I've got a vertical line going through them, touching the x-axis. So it's x equals -3. And again, if you were supposed to put it in standard form, you're supposed to move that over. Any questions? Let me see if we have another example, but I don't think that we do.